Okay, I should start with saying thank you guys staying for the third session of Cosmos DB. Thank you really very much. My name is Rafat Sarosh. I'm a program manager in Cosmos DB team. And today we are going to talk about IoT and Cosmos DB. The agenda of this session is that we'll quickly describe IoT reference architecture, quick overview of Cosmos DB. You guys had already 2 sessions about Cosmos DB. I will try to bring something new which you can use it in this weekend party when you're talking to your friends who are working across the lake in a big data space. And you can say why Cosmos DB is the best database. And then we'll discuss some use cases. We'll talk about how industry is using Cosmos DB with IoT. And in the end, I will show a sample, working sample with some code. So what is IoT application? If you see, it's a very simply 3 things are there. There are devices which are sending the data, and we gather some insights out of that data. And then out of those insights, we generate some actions to improve our businesses and processes. So those 3 things, when you take it to the production, it becomes a very complex thing, and you have to start worrying about a lot of different things, like how you will scale out the system, how the security should be there, where you will store this data, and who will own the data ownership. It has to be secure, because all of you are having smart thermostat in your home. Just imagine if somebody will get the hold of that data. There can be application. I know there are some jailbreak applications which will tell this house is empty now or not, because they triangulate with all your social activity and other things. So data is very, very important thing in this IoT. So now, quickly, let's look at the reference architecture, which is more or less, most of the IoT applications uses it in a very similar manner. But there are a few changes are there, and we will discuss them. IoT devices are sending the data to IoT hub. And from the hub, there are a couple of options we have to take that data. Sometimes we take this data directly to Spark, which you have seen in the first session. If you were here, how to use Spark to analyze all the data which is coming in. Sometimes you take the data directly into the storage, or the data come in storage after the Spark. And then that data can go to the business integration. As we talked about, once we have the insight, we can have the action taken to really harness all the data coming out of those IoT devices. And as you can see here, the main thing, and I will focus on because I'm from Cosmos DB team, is storage. As you know, there will be like 35 billion IoT devices going to be there. And each of these devices produce data like every second or 100 times in a minute. And not only in industrial places, but cars and these doors, everything is very soon going to be, everything will have IoT devices. So massive, massive amount of data is produced. And so the biggest problem now is where to save that data. And that's how I see that we are lucky also in the Cosmos DB team that we came in existence exactly at the right time when a lot of technology is converging. IoT is coming, and they need some database to store this terabyte and petabytes of data. So we'll quickly talk about Cosmos DB. I know you guys already heard about Cosmos DB. I will try to differentiate Cosmos DB with what other products we have in the market. Cosmos DB is born in a cloud database. That database completely born in the cloud, and our fundamental design principles were, when we started from the inception, was to have a global distribution, elastic scale out, guaranteed low latency, and 5 consistency level. Now, when I say global distribution, most of databases have a global distribution. But nobody come close to Azure or Cosmos DB. Cosmos DB is a ring 0 service of Azure. And Azure is in 52 data centers around the world. So if you will put Google and Amazon combined, still they don't come close to Azure. So that's one of the differentiating factors. Second, when you want to distribute this data, and if you've been through SQL, like most of us been in SQL, it's a big project. You have to set all this replication and figure it out. Or even if you are in NoSQL world, you have to do all this configuration and know a lot of inner working of your database to do the replication. In Cosmos DB, you'll go to a portal, there's a map of the world, and you will have all these data centers there, and you just go and just click. That's it, and that's it. And no other configuration is needed, nothing. Data will be replicated all around the world. And not only the data can be replicated, but you can have automatic failover, and you can have a manual failover also. So we say when you are on Cosmos DB, your application is always on. By that we mean so whenever you write the data, obviously it's written in 4 copies of the data written in the data center. But even if the data center blown away, your application will quickly flip to the next data center because of your global distribution of this database. And your customer who are using that application, they will just feel maybe a delay of 100 to 150 milliseconds, and your application will keep working. You will not find any glitch. Your business will not stop. And so that's automatic failover. You can do this failover manual also. Why you want to do that? Sometime, one of our customer, Domino's Pizza, they are in Australia, in Asia, and in Europe. And we have one region can be only the right region, and everything else can be the read region. So as the sun moves, they flip the right region from Australia to Asia to Europe, and that's why you do this manual failover. So all this thing is in Cosmos DB, and it's a very easy to do this manual failover. You can, of course, go to the portal and do that, or you can just write 3 lines of code, and that will happen. So that's one thing. Elastic scale out, you already heard about, we are scaling out big time, but storage is really infinite. You can just keep using it, no configuration, nothing. You don't have to figure it out what shards I should use and all that. It will just keep growing forever. And for throughput, we have customer who went from 1 million requests per second to 3 million requests per second. And then after 3 million requests per second, they come down and everything keeps working. So that's what we mean by elastic scale out. And I don't know how many other databases can just this way by 3 lines of code, and you elastically scale out for millions and millions of RUs. We call it request unit per second. Guaranteed low latency, of course, you know that it's a 10 millisecond read, 15 millisecond write. That's 99 percentile. But if you'll come to 70 percentile or so, we will read it in 2 to 3 milliseconds. So again, this low latency is pretty good in the market with our competition. But next one, we really shine there when we talk about 5 consistency model. If you see most of the NoSQL databases, they will have strong consistency or eventual consistency. And you have to choose just one of these between these 2 things, strong or eventual. And if you go to Cassandra, they may have 11 or so consistency level, and you have to be really a computer scientist to figure it out, fine-tune all this configuration and all. And you can make a mistake there that you keep just one replica of a data, and then suddenly you can get into trouble. So all that complexity we really taken away from the customer and just gave you 5 radio buttons where you can just go and click and choose one of the consistency level. So from strong, we have a bounded staleness, session, prefix, and then eventual consistency. Now, these consistency model also is, you are not fixed with it. Again, this is a differentiating factor. As we all know, as we will start developing something, no matter how much we do, the design on the desk before we start the project, but as soon as you start the project, you realize there's a mistake, I want to change the consistency level. In Cosmos DB, if you started with strong consistency level, you can change the consistency even on per call basis. So that's the flexibility which we have given to the customer. Again, this is, I don't know how many other NoSQL databases can do that. And with strong consistency, we have in preview strong consistency for multi-region. So you can have strong consistency in multi-region. So today, if you write data in one region and you get the acknowledge back, you know that data is written. But it's not many of our competition can do. For multi-region, we can have a strong consistency. Of course, we have a very comprehensive SLA, which is, again, financially backed SLA. Now, on top of this core platform, we build the multi-model. Multi-model database, and the reason is all the devs or all the enterprises want the flexibility. You want to keep the data the way you want. You just heard about graph database and document database and all column family and key value. So here again, it's just one database where we can keep all this different kind of data in one database. So you don't have to keep learning all different databases. Like if you see our competition, Dynamo database is for document, and then they have Neptune for the graph databases. So here, you can have everything in one database, and you can put the data in document form and then query it from the graph databases. So that's another beauty of it. And obviously, on top of this, you already know about, we have all this different client libraries and application. I just want to clarify one thing here very quickly, because a lot of people get confused that is there a MongoDB or Cassandra DB is inside the Cosmos DB? No, there is nothing. It's all Cosmos DB. We just learn how to speak MongoDB language or Cassandra language. We conform to the binary wire protocol of Mongo and Cassandra, and that's how all of these client libraries can talk to us. So that was a quick overview of Cosmos DB. And now coming back to our reference architecture, and we can see that we can put Cosmos DB now in this reference architecture. And what we are seeing, different options here. Sometimes you put the Cosmos DB in front, and using the change feed, I know in the last session you guys talked about change feed. I will go in much depth about the change feed and write and show you in Visual Studio how easy it is to use change feed with Visual Studio. So using the change feed, you can do the stream processing, and then you can take the data to the cold storage. And this is another option. But you know, with some variation, you have this big, broad architecture still remain as is because all these pieces are there. Now, as I said, on top, it's a stream processing, so it's a hot path, and then you have a cold path, which in last session you guys heard about. I don't want to repeat it, but you know, hot path means the data is incoming and you are processing. Now, in hot path, we generally put Cosmos DB because we can take 1 million requests per second or so. Now, if this block diagram I can replace with all the services which we have in Azure itself. As you can see on top, we have two options. We can have Spark or Azure Stream Analytics. And then in the cold storage also, you can use Spark. And this architecture is used often to do the recommendation. Some of our customers are doing the recommendation system because they have the data in cold storage, and using machine learning, they will have data back into Cosmos DB for when the call comes from the web portal, you can quickly look at the Cosmos DB and provide the recommendation. Now I'm going to talk about what we are seeing outside. 2 weeks back, I was in Houston, where we were talking to all these oil and gas companies. They all are using, this is their reference architecture. The data is coming from there to IoT Hub, and then they are taking it directly to Cosmos DB, and using this architecture, they can connect directly to reporting. What we have seen, when the oil gets drilled and you have this bits, the drill going down, it has to go in a certain direction. And if the direction is not proper, the drill bit can be broken, and that break can cost you $1 million. So what happened when the drilling is happening, data is coming back here, and using the machine learning, the course correct where the drill should go. And on where I showed the reporting, they have a huge big screen where some very, very experienced people are sitting and watching all the numbers and everything. There used to be a time, I think still it's there, they have special people who can hear the sound of the drill, and they can tell that drill is not going in the right direction, it's hitting some rock. And now we are replacing those people with machine learning by analyzing the sound and saying you don't have to pay these guys $5,000 an hour because we can do it with machine learning. So that's what we have seen this architecture in the field. And here's the picture of the drill bit. When I saw this, I was very excited, something very interesting. It's so much electronics and so much data is coming out of this drill. It's unbelievable. One of car manufacturer is using Cosmos DB, and they have this IoT devices. Almost 250,000 cars are using this device to send data to their data center to analyze, and real time they can find out if there's an accident happen and what's the temperature of the oil and things like that. Terabyte of telemetry data is there, and this data is coming with the speed of 1 million requests per second. That's what they have provision in Cosmos DB. So now I will take this architecture, as you can see, and simplify it in this way. So imagine we have a company which is providing this service. If you are in the car, you can press this button, SOS, like most of the cars have these buttons now, which will send the data to your center, and data comes directly in Cosmos DB, and then using the change feed and processing the change feed in Azure function, you can figure it out what's happening and who to send the notification. And if there's an accident happen, you can trigger, like within less than 30 seconds, you can dispatch an ambulance, call 911, and you can inform the nearest hospital. And this whole project I will show you in the code, and that's where we will drill down in the change feed. And the same project I did a couple of years back for Kuwait Police. It was multi-million-dollar project, and almost 10 companies were involved. That time phone, and didn't have even GPS. We had the big Nokia phones, and we had a GPS. We drilled on the car, we put the GPS, and then got the GPS data in the phone, and through SMS send that data to their control center. But now, because of all these IoT devices and IoT hub, it's all so simple. Like this whole project, you can do it in a couple of days. So let's talk about a little bit more about change feed. As you heard in previous session, the change feed is a log of whatever is happening inside the Cosmos DB. You should think it as it's a window by which you can look inside Cosmos DB and see what all changes are happening. All the insert, deletes, updates, you can see it through the change feed. So there are many usage of change feed. One is you have seen you can use it in Spark to do processing, move the data to cold storage, or take the data to Azure Functions. So once the data is in Azure Functions, it is a C# code. Actually, sky is the limit. You can do just whatever you want. Everything is possible from there on. So let me now quickly show you a demo how this whole thing looks, and then I will show you in the end the code also. So this is my map showing, on my control center, I'm looking at the map, and using an IoT emulator, I will send some data. And for that, I will show you after this code also. Just give me a second. Now, here is, I am reading change feed, but we'll go more in detail. But for now, I'll just run it just to make sure everything works, and then we'll go dig deep into it And it's so simple, like it will just take 2 minutes to understand. So I'm running an Azure function, which is, so here's the Azure function, which is listening to Cosmos DB change feed. And this Azure function is natively integrated with change feed. To read change feed, there are 2 or 3 ways you can do that. We have our own client library. Using those client library, you can use the change feed. You can have a scale-out solution. You can have multiple listeners. They are listening per partition, and all that you can do. You can go back your checkpoint, and you can move forward. You can do a lot of things. But with Azure function, it's as simple as that. You start your Visual Studio, click Azure function, and give the collection name, and it's connected, and start listening to the change feed of the data, which is coming in Cosmos DB. And here's my one IoT emulator, which is going to send some data to emulate an accident. And this is the place you become nervous. You wonder if your demo will work or not. It better work. So you see the change feed, and quickly you see where the accident happened. And if you will see, if you remember what we showed you before, this is what happened. The data has come in Cosmos DB again straight, and using the change feed, I'm listening the change feed, and looking at the data, I said, okay, there's an accident happened, and just put that data in a notification queue, and it just notifies all this. So now let me show you the code. So here, I don't know if you guys can read it. Let's make it a little bigger. Is it clear? Can you guys read in the back? So Visual Studio is integrated with Azure function, and Azure functions are integrated with Cosmos DB. So it's as simple as starting Visual Studio, saying I'm writing a Azure function for Cosmos DB. And once you define what are your collection, you see this one method comes out, which is run. And using the attributes, you just define the collection name and database name. And in this function, you see that you have a list of documents. So all the data which is inserted by the IoT device in the Cosmos DB is all showing up here in this function. And then you can just go over this function and look for, okay, if there's accident happen or not. So I use this IoT ID, AAA. You can use anything else. And here you can see I'm defining a cloud queue, and I'm just putting an even there, queue add message. And my other apps are listening, and just that they update the map. Now here, I showed you that how you can connect to cloud queue. Actually, this also you can define an attribute and just return. So it's just 4 lines of code, reading the change feed, and this whole application is in a, you can have a working prototype in a day or 2. So this is it. This is all I wanted to show you very quickly, how you can use Cosmos DB and change feed for your IoT system. And my time is up. But if you guys have questions, we can quickly take some questions. But later on, also, you can send me questions in the email, or askcosmos@microsoft.com also is an alias which we monitor, and send your questions there too. Okay, thank you. I will share this code with you too. It's all on GitHub. We can share that code.